Okay, so this is 18.1, solving equations by factoring x squared plus bx plus c. So we're going to factor these quadratic equations, and then we're going to use the zero product property to solve the equations. So we're going to factor first, and then use the zero product property to solve quadratic equations by factoring. Okay, so the first part of this Explorer 1 is using algebra tiles to do the factoring. We're not going to take the time to go over how to use these algebra tiles to factor. It is a process that you basically try to build rectangles with these tiles, and then those rectangles show you or tell you how you could factor a quadratic equation. But again, I don't think it's something that is worth the time that you have to invest into it, because it doesn't really then, tell you exactly what you need to do when you don't have the tiles. So we're going to go ahead and start then on page 879, and we are going to factor trinomials, learn how to factor trinomials in the form of x squared plus bx plus c. Okay, so the important part of this method that we need to understand is that in using this method that we'll go over in this section, the leading coefficient needs to be a 1. Okay, it needs to be 1x squared plus bx plus c, meaning that the coefficient of x squared is a 1, meaning that it's just x squared. Okay, the next section, 18.2, we'll look at how we do this kind of factoring when a is a number other than 1. And a being this coefficient of x squared, that's ax squared plus bx plus c that we've been calling standard form. Again, today we're only going to be looking at situations where the coefficient of x squared is a 1. So what it says here is that to factor a quadratic trinomial of the form x squared plus bx plus c, find two factors of c whose sum is b. Okay, if those integers don't exist, then the trinomial is not factorable. Okay, so not all trinomials are factorable. If they are, then you would be able to find two numbers that multiply to c and add to b. Okay, so they give you an example here of factoring x squared plus 9x plus 18, where we look for factors of 18. So factors are just numbers that multiply to equal other numbers. And we need those two factors to also have a sum of 9. So what we can look at is if you guys can please be quiet. Okay. So what we can look at is two numbers that multiply to 18, because that would mean they're factors of 18. And those same two numbers that multiply to 18 need to also add to 9. So here are the factors of 18. You got 1 and 18. Well, that sum of those two numbers is 19. So that's not going to work. 2 and 9, once again, they do multiply to 18, but they do not add to 9. And then you got the 3 and the 6. 3 times 6 is 18, so 3 and 6 are factors of 18, and 3 plus 6 is 9. Being that those two numbers do multiply to 18 and add to 9, that means that we can factor x squared plus 9x plus 18 into x plus 3 times x plus 6. And in rewriting it that way, we have factored that trinomial. Okay? So they give you another example here, and I'm going to show you a method that you can use to do this type of factoring. Okay? And what we're going to do is we're going to draw an x, a pretty good size x. And what we want to do is put the last number, which would be what we call the value of c, which is a 30. We want to put that on the top section of the x, and the b value, which is the middle coefficient, on the bottom. And what we'll need to find is we'll need to find two numbers that multiply to the 30. In other words, multiply to that top number, but those same two numbers we'll need to add to the bottom number. And so you start thinking about numbers that multiply to equal 30. You got 3 and 10, right? 3 times 10 is 30. However, those two numbers have a sum of 13. So that's not the combination we're looking for. You got 15 and 2. Once again, they multiply to 30, but they add to 17. Not the combination we're looking for. So the combination we are looking for is 6 and 5. Very good. So 6 times 5 is 30, and 6 plus 5 is 11. So what we can say is that will factor, this trinomial will factor into x plus 6 times x plus 5. So you can see that 6 and the 5 are what we're going to put after each of the x, positive 6 and positive 5. Okay, so that's, like I said, that's going to factor into x plus 6 times x plus 5. So they break it down for you sort of a step at a time here in these steps here, part B. What they're saying there is that because c is greater than 0, what that does mean is that the two signs in the parentheses will be the same. And because b is greater than 0, that actually means that they will both be positive, plus and plus. If c was greater than 0, in other words, if this was positive, but this sign right here was subtraction, meaning it was less than 0, then both of the signs in the parentheses would be subtraction. But that's a step that's not necessary if you'll just find two numbers that multiply the top number, add to the bottom number when you make the x, then that will determine whether it should be, you should have pluses or minuses in your parentheses. Okay, so and then part C, they do the factors. So you say 1 and 30. Well, of course, those two have a sum of 31. We got 2 and 15. Those have a sum of 17. 3 and 30, which have a sum of, not 3 and 30, sorry, 3 and 10, which has a sum of 13, and then the 5 and the 6 combination is what we needed because they do have the sum that we needed of 11. So the factor pair whose sum equals b is 5 and 6. So that would then mean that we can factor that trinomial, as we have already done, into x plus 5 times x plus 6. Now then, they give us another example here. So again, we're going to make the x. So this is how I want us to do this when we're factoring these trinomials, where this, again, that first number in front of x squared is a 1. Now we need two numbers that multiply to negative 30 and add to 13. So because they need to multiply to a negative number, that indicates that one of these numbers that we're going to need here is going to have to be negative. Because when you multiply and get a negative number, that means one of the numbers is negative. So two numbers that multiply to negative 30 and add to 13. Okay, so you start going through all the different combinations of numbers that multiply to negative 30, and we need the combination that will also have a sum of 13. So those two numbers would be a positive 15 and a negative 2. You multiply those two, you do get negative 30. You add those two, 15 plus a negative 2, which is just the same as 15 minus 2, that is equal to 13. Okay, and so as they continue here, they're going to go through kind of the same kind of steps here. But if we'll just find those two numbers that multiply to the top number and add to the bottom number in the x, then we can determine what the factors of this trinomial are, which in this case is going to be x plus 15 and then x minus the 2. And that's how you would factor that trinomial. Okay? Again, you could go through these different steps here, and eventually you would find that the combination is the positive 15 and the negative 2. That would be the combination that we're looking for. Negative 2 and 15, negative 2 plus 15 is again that positive 13 that we were looking for. Okay, the next part is using this type of factoring to solve a quadratic equation. So we're going to use the zero product property along with this type of factoring to solve quadratic equations by getting them into this factored form. Okay, so step 1 is going to be we need the equation to be equal to 0. Okay, so we need to write the equation in the form of x squared minus bx in this case, or in general it could be a plus px plus c equals 0. So what we need to do is take this minus 12, this negative 12 that's on the right side, and add 12 to both sides. So the equation would then be equal to 0. Okay, which is what you can see that they've done here, and wrote it as x squared minus 8x plus 12 equals 0. So at this point we're going to use that x method of factoring. We're going to draw an x, put the last number in what we're factoring on top. That's the two numbers we need to multiply to, or we need to find two numbers that multiply to that. And these two numbers will need to add to a negative 8. So what two numbers multiply to 12 and add to negative 8? Well, because they need to multiply to a positive number and add to a negative number, that means that both these numbers are going to be negative. Okay, so we need two negative numbers, and that will multiply to negative 12 and add to negative 8, and those two numbers are going to be negative 6 and negative 2. Okay? And you can see that those do have the sum of negative 8 that we do need here. So that tells us that we can factor that trinomial into x minus 2 and x minus 6. And because we've made the equation equal to 0 in our first step, then we can use the zero product property, where we say that if this is going to be equal to 0, if x minus 2 times x plus 6 is equal to 0, then either x minus 2 must be equal to 0, or x minus 6 must be equal to 0. In order for x minus 2 to equal 0, x would have to be a positive 2. In order for x minus 6 to be equal to 0, x would have to be equal to a positive 6. And so those would then be the zeros of that equation, and therefore they would solve that original equation that we started with. Okay? And you can see that if they graph that related, the related function here, that you do get the x-intercepts at the 2 and the 6, so that's a graphical way to confirm that the solutions are 2 and 6. And you could go back to the original equation and check them and see that when x is a 2, you would get an equation that's true, and when x is a 6, you would also get an equation that is true. All right. So, looking at this one here, the first step is going to be subtracting 15 on both sides to get the right side to have a value of 0. And then we're going to need two numbers that multiply to negative 15 and add to a negative 2. So what would those two numbers be? So you start thinking about numbers that multiply to negative 15 and then see if they add to a 2. In this case, those two numbers are going to be a negative 5 and a positive 3. Those two numbers have they do multiply to negative 15 and they do add to a negative 2. Okay, you see there, so you got negative 5 and 3 plus negative 5 is negative 2. So is negative 5 and 3. So we can say that that will factor into x minus 5 times x plus 3. It does not matter what order those go in. It could be x minus 5. Now the 5 has to go next to the minus sign and the 3 has to go next to the plus sign, but the x minus 5 can be written first. It is not going to, multiplication does not depend on order of the numbers. And so then we can use that zero product property to say that if x plus 3 times x minus 5 is equal to 0, then either x plus 3 has to equal 0 or the x minus 5 has to be equal to 0. In order for x plus 3 to equal 0, x has to equal negative 3. In order for x minus 5 to equal 0, x would have to equal a positive 5. You can see that they confirm that with graphing or by graphing. And we definitely use Desmos to do that kind of confirmation there. All right, and so that is about it. They do, well, let's go through this last problem where we're using this method to solve a quadratic equation. So they say here that we've got the dimensions of a rectangular porch along with the area of that porch, and they want us to solve for x. So by taking the dimensions and multiplying, we can get an expression that represents the area. And here at this step, they multiply those two together and they get x squared plus 17x plus 60. Well, this area is equal to 120, so they substitute 120 for a at that step. And then, like we've said, in order to use this method, we've got to make the equation equal to 0. So they're subtracting 120 from both sides at that previous step to get this equation right here. And then at this point, we need two numbers who multiply to negative 20 and add to 17. And those two numbers would be, in this case, a positive 20, and a negative 3. Okay, and so we would determine that those are the two numbers there. So the factors are 20 and negative 3, meaning that that trinomial that was created here for this situation can be factored in x plus 20 times x minus 3. And using the zero product property, that means either x plus 20 has to be equal to 0, or the x minus 3 has to be equal to 0, and meaning that x would have to be either a negative 20 or a positive 3. Okay? So problems I'd like you to do are 4 through 16, and you only need to do the even, so 4, 6, 8, 10, 12, 14, and 16. And then also 17 and 18. Okay, so that's 2 through 16, excuse me, not 2. 4 through 16 evens, and 17 and 18. Okay, and that will be due on Wednesday. All right, thank you, and if you have any questions, please make sure that you ask during class.